Okay, hello, everybody. I'd like to call to order the 109th meeting of the BTNEP Management Conference here in the beautiful Blue Works building down here in Houma, Louisiana. We're going to dispense with a normal roll call because we're using a sign-in sheet form. So if you have not signed in, please do so before you leave so that we can record your attendance here. And with that, I want to ask Dr. Brian Roberts to give us a welcome.
Thank you, Quentin. Feel kind of strange because there are, I think, more people behind me than there are in front of me here. I'm gonna just stand over here. I just wanted to welcome you all to the first of our new facilities at this Houma Maritime campus that we're really happy to share with Fletcher Technical Community College. Has the building right across over here. We were able to do the ribbon cutting on this Blue Works building last December, filling it with programs and staff. You'll see there's a lot of activity also going on back here. This is the boat slip and bulkhead for the regional class research vessels that are being built right across the way here. That sometime before I retire, we will get them delivered. And also we'll be able to use this as the safe harbor for all of our research vessels, including the pelican replacement. And then about to send out the bids, the bid request for our new Marine Operations Center, which will also be behind here. So for those of you that want to stick around afterwards, happy to show you around the facility, but I know we've got more important things to get to today. So just welcome and thank you for coming to see some of LUMCON's new facilities.
All right, thank you, Brian. And again, thanks for having us over here. This is a really nice facility. Next, we have approval of the agenda. Everybody's looked over the agenda with it. So we'll mark a second. That over here. All in favor? All right, okay, good. And next official thing is to approve the minutes from our 108th meeting. You want to make a motion? We got Dustin. No. What's your name? Dwayne. Sorry, man, I'm getting old, all right? It happens sometimes. All in favor? Okay, all right, so we agree. Okay. I do not have any specific remarks, so I will move on over to old business. Any old business announcements to make?
Thank you, Dr. Fondo, and thanks to everybody for being here this morning. Just a couple of things I wanted to mention, a couple of announcements. One, a request, I guess. Just it occurred to me as we were developing the agenda for this management conference that this is your management conference, and if there are topics or things that you want to hear from program staff, or things that you want to present to the conference, just want to throw it out there that we're all ears and are open to suggestions. So if you got some ideas, if you hear a great presentation that you think would be appropriate to be heard here at the management conference, please let us know, and we'll work those things in as we can and have it appropriate. And then the other thing I wanted to mention is I'm happy to say the title graph calendars are in. Hot off the press, we literally got these on Tuesday. It's a beautiful calendar this year. The topic for this year, the theme is amphibians of our estuary. So lots of good photographs of the squirmies and squigglies that a lot of us are pretty fond of. Some of us maybe are not, but all the features you're used to in the regular calendar, and we do have a couple of boxes of those here today. So there's enough for everybody to pick up a couple, 2 or 3 on your way out, and we'll start distributing these throughout the estuary. So I did want to give Natalie Waters an opportunity to talk about this. One of the neat things to me about this calendar is actually the theme is a result of one of our projects, a publication that was produced about amphibians in Louisiana. And I'm going to ask Natalie to just say a little bit about that real quick.
Good morning, everyone. So as Brent mentioned, this year's title graph calendar theme is amphibians of our estuary, where we highlight 12 different species of amphibians that we find in our estuary. Amphibians are important indicator species within our ecosystem, so we wanted to give them the spotlight this year. We want to thank Brad, also known as Bones Glorioso, who is a ecologist and herpetologist who works with USGS. He provided the information and the beautiful photos for this year's calendar. Also want to thank the BTNEP staff. It is a group effort to make these title graph calendars, so thank you to everyone who contributed. Like Brent said, we are going to be handing these out, so please don't forget to grab some on your way out. Thanks.
All right, and I had a chance to get a preview of the calendar, and the photos in there are incredible. I think I got most of them in the backyard. Okay, any more old business or announcements? All right, new business. We've been asked to admit a new member to the management conference. This is the Louisiana STEM. It's directed by Christy Landry. They put their petition forward, and one of the requirements to do that is to attend several of our management conference meetings, and they've attended the last 4. So they've met that criteria for being here. They have a strong presence at our meetings. I don't know if there's any discussion about this, or somebody wants to make a motion. So Dustin, second. Jonathan Forey, seconded. All in favor? All right, congratulations. We got a new member of the management conference. Thank y'all. Okay. Yay. All right, next is up is our director's report.
All right. Well, thanks again, Dr. Fontenot, and glad again to be here. See where we are on the slide deck. All right. It's been a busy quarter. Happy to update you all on about some of the things that have been going on. As we know, in South Louisiana in particular, spring and fall are big time festival and event time periods across our coast. And certainly that's been the case in the Barataria-Terrebonne National Estuary. And we've been fortunate to participate or host a number of those things. The first of which was in kind of the latter part of September. We participated in International Coastal Cleanup, partnering with Nicholls State University and the Department of Wildlife and Fisheries to help clean up the public beach there on Elmer's Island. So almost 90 volunteers participated in this. It was a large group. We collected almost 700 pounds of trash over about a 2-mile stretch of the beach there to keep it nice and clean for the public to enjoy the natural resources of Louisiana. We followed that up not very long after that with a white boot gala. I know Dr. LaFleur is going to speak a little bit about this. I won't steal much of his thunder, but it was a resounding success. I'll just say that. A lot of fun, broke records in terms of attendees, tickets sold, sponsorships, and funds raised. And so you can see some of the folks there. That's me, of course, with 2 of our former directors. You can see the packed house in that middle photograph and some of the more festive decorated white boots that were at the event as well. So looking forward to participating and hosting that again next year. Little after the White Boot Gala, we hosted a native plant giveaway. This is a project or an effort that's funded through a U.S. Fish and Wildlife Service grant as part of their pollinator conservation program. But we had switched gears on this one a little bit. Typically, this is done at or has been done in the past at the Lowe's in Thibodaux. We shifted it to the farm for a couple of reasons. One, that's where the plants are, and it's easier on staff not to have to move everything to Lowe's. But also to get some exposure to the farm, both for BTNEP and for Nicholls as well. We had over 100 visitors that day, gave away over 1,200 plants, many of which were trees, as you can see there. Another great event, Paddle Bayou Lafourche, was held about the middle of October. We had over 75 participants there. There were 2 options, a 15-mile paddle or a 9.5-mile paddle. It was a great day. The weather was gorgeous. Saw lots of interesting wildlife. Was able to really connect with the bayou there, which of course is really the heart of the estuary. On a personal note, I did not paddle. I was actually in the chase boat, which, if you're not aware, broke down during the event. So thankfully, we had a makeshift mechanic in the boat with me. We were able to disconnect an hydraulic line, lash a paddle to a motor, and somebody worked the throttle while I was on the back using the makeshift tiller handle with the paddle. I'm told this wasn't a new director hazing ritual, but I have my suspicions. Other events, and I'll not belabor all this too much, but you'll see that we've got some folks that were at the WYES Expo at their studios there in New Orleans. Back in September. We also took a little time to do some professional development, which I'm hoping to do from time to time. We had Dr. Charles Allen visit us, and we spent some time both at the Nicholls Farm around Lake Buff and Bayou Buff and on into Lake des Allemands, in fact, and then also at Grand Isle and Elmer's Island, learning about some plant identifications that that will be able to in the future as we're implementing projects, identifying habitats and so forth. So that was a nice time, a good thing for us to do. We participated in Rougarou Fest, and I'm happy to say that you see Delana LeBlanc, except the cutting in and out, it sounds like, but we're very thankful to have received the Coastal Champion Award at the court that it's sponsored by one of our partners. I think I saw Jonathan here, the South Louisiana Discovery Center. Great festival, and it was a good time. Of note, you'll see what I think should have been Halloween contest winner, Delana at the bottom there, wearing her Halloween costume. On the right, you see that we participated in the Yellow Rails and Rice Festival. Yeah, we're on. Can you hear me? Yellow Rails and Rice Festival toward the end of October. This is not actually in the estuary, but it was a great opportunity to expose BTNEP and some of our materials, particularly related to our natural resources, birds in particular, in the estuary, to folks from, I believe there were folks there at Delana, correct me if I'm wrong, but from 40 states around the country. And you can see them here. It was a little bit of a tough year for sighting yellow rails. This was one of the very few that they saw. You can't see it; it's there in the rice straw, but they were able to surround it and hopefully not stress it out too bad and be able to view a yellow rail there. A couple of other things that have occurred. You see Ocean Commotion that was held in Baton Rouge on November 1st. You see Andrew Barron there, Siva Noon was there as well. This was a great event. We reached over 2,000 students. There were 34 schools represented there from 11 different parishes. So just a tremendous event that's been going on for quite some time. We're very happy to be a part of it and teaching these youngsters about various species that live in the estuary, water quality, and the importance of clean water within our environments as well. And then just the day after that, actually, some staff participated in the Future Farmers of America statewide competition that was hosted at Nicholls State University as well. So, of course, since our last management conference, we have experienced Hurricane Francine. It was certainly disruptive and damaging to a lot of folks. I did just want to report out that we were very fortunate at BTNEP that our office facilities did not really sustain any damage at all. We had some minor damage at the farm, nothing really too major. The biggest thing that we experienced there was a very large water oak that fell from a neighbor's property onto the farm property adjacent to our boat shed. It damaged the roof kind of in a minor way, and staff were very quick to begin cleaning that up. We're very close to having that removed from the property altogether. But all things told, much more fortunate than some of our other neighbors within the estuary. I'm happy to report that since we last met, the EPA has approved both of our work plans for this federal fiscal year. So the base funding plans, the Clean Water Act, Section 320 funds that come to the estuary, the projects that you all have reviewed and approved for submittal to EPA were approved in addition to the projects that were in our bipartisan infrastructure law work plan. So you list 16 projects there. It's actually more than that when you consider things like the calendar and some of the other projects that we do internally. But a good number of projects that will be underway. Those of you that were subawardees for these projects, if you haven't already been contacted, you will be contacted soon by staff to start getting agreements in place so that we can be rolling these projects out over the next year or two. So that's great news. I mentioned at the last management conference that we've been working with Lacey. I saw Lacey here a little while ago. There she is. So thank you very much, Lacey, for all your cooperation and work with us. We're progressing nicely in terms of trying to acquire some new office space at the Nicholls Coastal Center. You see just some updated photos here on the left. You see a picture of the building itself. In the middle there, sort of the main entrance and main stairway for the building. And those photos on the left are actually photos of the office space that we will occupy when it comes time to move in. And big news, hopefully most of you have seen this. I know many of you know Michelle, but we have hired a new deputy director. So Michelle will actually start on Monday. Michelle is comes to us from CPRA, where she worked on, she's a senior scientist at CPRA, worked on things like the Southwest Coastal project, the Chapelizod Basin program, and worked very closely with LUMCON and others in terms of trying to establish the National Estuary Research Reserve. She holds a master's in marine and environmental biology from Nichols State University. And she also has a law degree from Tulane, and as you can see, is no stranger to the to enjoying our estuary. Some of the photos that are there, and we're very excited to have Michelle on board and helping us to managing this program in the way that it needs to be managed, and getting us down the road and getting some good work done in the near future. So very excited about having Michelle on board. And lastly, I'll just mention that our last couple of work plans were just approved, which means it's time to start thinking about the next one, right? And so just a heads up is basically what this is, that solicitation should be coming out sometime in the next month, maybe a month and a half on the far end, but we're trying to move things, move the schedule to the left a little bit, if you will, so that we can have a little more time for us all to be able to contemplate what projects we might want to do and review those as a management conference to ultimately make our decisions through the action plan teams and then ultimately management conference. So just be on the lookout for that. You'll see an announcement sometime again, hopefully within the next month or so, about solicitation for the next work plans. And that concludes my presentation. I appreciate your time. To answer any questions if you have. Dr. Bowman?
All right, up next is Dr. Gary LaFleur for the foundation report.
Thank you. It's good to be here. You know, my day job is at Nichols, and Nichols is one of the consortium members of LUMCON, and I'm proud to have been collaborating with LUMCON since before the turn of the century, like some people that are also in the room. And I'd like to kind of, before I get started, salute LUMCON's wisdom in creating a center like this. They're keeping the Felice Center at Cocodrie rolling. It's still there. But this is the wisdom that we probably all should follow as example, exemplified by LUMCON, realizing it's good to have something a little more north, both sides of the estuary. That makes sense. So I appreciate us having the meeting here today. But that's not why I'm here. I'm here representing the Barataria-Terrebonne Estuary Foundation. And the main thing I wanted to say was thanks for showing up at the White Boot Gala. That's what the estuary people do. They show up. And that was really recognized this year, because this year the funds that we took in were 4 times more than last year. Not 4%, 400% more. You know, that came with a lot of work from the program, especially Nicole Babin and Emily Noblock Bombeland. We appreciate y'all's help. The Estuary Foundation was there too, but really the people in the room were there. We appreciate y'all being there. It shows that you care about the program, right? The funds are not really for the foundation, but they're there for the program. I wanted to make sure that y'all knew about some of our sponsors as well, so that you can tell them, hey, thanks for supporting the estuary. We had some big sponsors from Joe Signs, that's in Houma, Lowlander Center, which is sometimes at the table here, CF Industries, Louisiana Wildlife Federation, which is at the table here as a management conference member. The Fletcher Foundation came through for us. We appreciate that. Joe Ogeron's campaign fund and Synergy Bank. The biggest supporters remained anonymous. We appreciate that. That's kind of like putting your money where your mouth is without even seeking any credit for that. So we really appreciate that. And then the next thing that people wonder is, well, what's the foundation do with that money anyway? Well, a lot of the slides that Bryn showed were things that we helped out with. The foundation is ready. We're just walking distance away from the program. So when the program needs some supplies real quick for the biofilms cleanup, that's what the foundation is there for. We can make quick decisions, get the money to them quick. For the paddle trip, boom, we helped out with that today. The foundation is partnering with LUMCON to host this meeting because LUMCON gave us this beautiful spot. The foundation is sponsoring lunch. So that's the kind of thing that the foundation does. We appreciate y'all's help with that. That's it from the foundation. Thanks.
So, I'm a trained fisheries biologist. All of my degrees have the word fish in them, LSU and Clemson and all. But I was a student worker for wildlife fisheries when Hurricane Andrew hit. And I saw firsthand the fish kills that were caused, basin wide. It was incredible. So I was part of that, evaluating the fish kills and then the restocking of the basin after that. So Robby's up next, Mr. Robby Maxwell from Louisiana Wildlife Fisheries, and he's been tracking hurricane-associated fish kills. And so this is something that I've always been very interested in. It's one of the things that got me into fisheries, but when I saw that. So I'm really looking forward to seeing what Robby's got to say. Thank you.
While they're setting up, I want to go ahead and introduce Robby. So, Robby, he is going to present today on tracking the fish kills in Louisiana following Hurricane Francine. Robby Maxwell is a biology supervisor with the Inland Fisheries section of the Louisiana Department of Wildlife and Fisheries. He obtained his bachelor's degree in aquatic biology and his master's degree in aquatic research from Texas State University. Presently, he works on inland fishery issues, including fish kills, fish contamination, habitat conservation, state wildlife action plan policy, and regulation, and other issues as needed. He is heavily involved in the American Fisheries Society as well as restoration efforts involved with the catfish and issues, including serving as the warden for the Southwest Louisiana Master Cajun Prairie Habitat and Preservation Society, and the Louisiana Native Plant Project, and the Louisiana Native Plant Society. So, Robby, take it away. Thank you.
Thank you. Drove down a lot of new roads for me today and ended up in this beautiful building. So thank y'all for having me out here. It's my first real time standing up in front of people presenting what we saw after Hurricane Francine. So I'm happy to do it. We're just gonna do a real quick overview of the hurricane, what we saw, what we're going forward. So Hurricane Francine hit September 11th at 5 p.m. and made landfall near the mouth of the Atchafalaya River. It was a category 2 for a hot minute and went to a 1 and had 100 mile per hour sustained winds. It did weaken to tropical storm over Lake Marpol at about 10 p.m. This is a map that we're going to see a version of in a few slides after this. This is a track of Hurricane Francine, the line. The red, darkest red down here is hurricane force winds. The kind of orange next to it is strong tropical storm force winds, and the yellow shaded area is going to be weak tropical storm force winds. So fish kills, we always expect fish kills in big tropical systems. Really, anytime a big rainstorm comes by, especially after a drought like we've been having, I expect fish kills. Halloween, we had big storms. So on Halloween evening, I'm thinking, man, I'm gonna have fish kills for a couple of days. And sure enough, Monday, we had fish kills. So we prepare for these, and we know they're coming. We've been dealing with these for years, just like Quentin said. Going back decades, we've been doing fish kill response. The primary reason for fish kills is biochemical oxygen demand, BOD, and that comes mostly from the microbial breakdown of debris and dead fish. Bacteria, fungus, they breathe oxygen too, so when they start breaking down debris, there's robbing oxygen from the aquatic life that's usually there. And then in turn, fish die, they start rotting, and the cycle continues. We also see increased BOD a lot of times in the summertime from algal blooms and really just some cloudy days. That algae will have a bloom because of increased nutrients, seasonal change, whatever's causing it, it'll die, it'll break down. Again, what's decomposing it is breathing oxygen. And also what shocks a lot of people is you have 3 or 4 cloudy days, say in July or August in the marsh, we start getting fish kills. That's because plants and algae start breathing oxygen when they're not photosynthesized. So it happens every night, and a series of cloudy days, we have fish kills. these kills change in place and time. We always look at things, if we go out and sample, that's a snapshot, but we have to always think that these are dynamic processes that are happening. We get a snapshot, but that's not the end of it. So in a hurricane or a big tropical storm, the main contributing factors are going to be the churning of sediments, turnover. We have a lot of debris in the bottom of our waterways that turn up, a lot of anoxic substrates. They start rotting. Debris washing into waterways, again, rotting. Receding floodwaters. So a lot of times that shallower water up in a flooded area is hypoxic or anoxic, and then it starts flushing down into the system and bringing more stuff that is rotting. We also see a lot of stranding, and it's if you're there after the fact, it's hard to tell if the fish were stranded before or after they died. A lot of times that water comes down and will leave kind of a mat of dead fish on the bank. But we all see with high waters, fish swimming in driveways and stuff like that. And when that water goes down, a lot of these fish get stuck in driveways and die. Storm surge and salt water can also kill fish, but this is kind of like the water moccasin of fish kill causes. Every water snake everybody sees is a deadly water moccasin. We know it's not. Many of the calls, vast number of the calls I get about fish kills after a storm, even if people are way inland, oh yeah, the storm surge killed the fish up here, storm surge. That's, I think, a very common explanation for people seeing dead fish, when from what we see in it's actually much more minor. It's a fairly minor cause for fish kills after a storm. So please do your part. And if you hear somebody saying storm surge killed their fish, please correct it. Help us out. And these kills are widespread, and they go on for an extended period of time after a storm. We see hypoxia up to a month after these big storms a lot of times. So when we knew a storm was coming, we did some of our background work, got in touch with all the coastal districts. Hey, storm's coming. Let's try to get a little overtime approval in case we need it. Y'all just be ready to go out and start counting dead fish for a couple of weeks if you need to. We're looking at dead fish. So we know it's coming and we're ready. After the storm, we monitor phones. People call into our hotline. People call into the district offices. They call into my office. They call friends of friends of friends that get to us. I monitor social media. I learned during Laura, which impacted me, I live out towards Lake Charles. I learned that social media could be a gold mine for fish kill reports. So when Ida hit and it didn't affect me directly, I could really dive into social media, and I really saw the value of that. So I've started doing that. I go on Facebook and YouTube and just start searching fish kills. And a lot of stuff comes up, and joining little local groups, like the Maurepas group and local basin-wide groups. The news, sometimes the news outlet reporting, and there's dead fish that's the first place we see or hear of a fish kill. And emails. In the end, we got 89 reports of fish kills after Hurricane Francine, that's a lot. And it's more than we got for Ida or Laura, but really that is an effort, and that's refining technique. It's not that there were more fish kills by number, it's just we're getting better at tracking. 50 of those came from LDWF and 39 came from the public. Our crews, we had 4 inland districts and a coastal district that were out looking at dead fish following the storm. And our inland districts were taking water quality data from the 13th to the 25th to just kind of track where the hypoxia was. So here's a map of the compiled fish kills. The public called in kills are in blue. LDWF reports are in black. There's a lot of overlap. So if I zoomed into this map, you'd see a lot more little dead fish symbols. But they were reported from the 13th of September. That was our crews out 2 days after the storm in the lower Atchafalaya. Saw some dead fish. We're measuring hypoxia, which usually takes 2 or 3 days for them to start showing up. By the time Monday or Tuesday rolled around after the storm, I was getting lots of calls. The first reports I was getting was heavily in the Maurepas Basin, Blind River, Amy, the Virgin Canal. And then the next day after that, I got a lot of calls from Bell River, the drainage going to Lake Barrett, and otherwise we got them from all over the place, just scattered after that. It does cover about 2 million acres if we just connect the dots on the dead fish. For scale, Hurricane Ida was about 1.8 million acres, so I did the same thing. And there's a lot of overlap with that Ida. This kill went a lot further west and northwest than Ida did. A lot of the reports I got were not of big mats of fish, not everything's dead. It was a lot of, I saw fish piping, being up to the surface, trying to get that oxygenated water to the surface. The next day they were rolled up dead in my boathouse. But today there's more fish swimming over here. People out of Thibodeau called 3 days in a row, we've seen piping fish and there's new dead fish coming down. So it was very dynamic, and it was, in the end, I'm saying it was a spotty kill. It was a very scattered kill, and fish were searching for refuge this whole time and finding a lot of cases. But a big storm like Ida or some parts of Laura, but really Ida was mats and mats of dead fish. It was a very deep, substantial kill. It wasn't like that for this one. Our crews went out and took water quality for almost 2 weeks after the storm, trying to get an idea of where hypoxia was happening. This is also, one, it has them on the water looking for more fish kills. And two, we can get hypoxia readings where there's no sign of dead fish, which I just saw the other day at Abbeville. We had a bunch of fish kills out in the Abbeville, Liberia area. And by the time I got out there, the water had come up and gone down. I think I saw a total of 5 dead fish, but you could smell it and there was virtually no oxygen in the water. So these hypoxia readings, when it goes to connecting the dots to see how big a kill is, they're really important because there might not be dead fish at a fish kill. We took 260 samples. 162 of those had a dissolved oxygen under 2 milligrams per liter. That's the EPA standard. Seems like fish in this part of the world and a lot of aquatic life has evolved through these repeated events to deal with a little bit lower dissolved oxygen conditions, but that's still the measure we're using because we do see very low oxygen levels with fish that aren't breathing air, swimming around and eating other dead fish. We had 98 dissolved oxygen readings that were above 2. So that's more than a third of the areas we sampled had good oxygen readings. And we took a combination, again, this is 4 crews going out and taking water samples. They took a combination, some, depending on what the water looked like, they took 1 reading, maybe in the middle, and we do have surface and bottom. So I don't know if you can see it where y'all are, but some of these dots, what we're looking at here is the red dots are hypoxia. The white dots are, quote, good water. Through lots of tweaking with my limited GIS skills, I got it so it can show if we have a split in oxygenated water and hypoxia. So if you see a red dot with a white ring around it, that means the bottom was hypoxic and the surface had oxygen. So maybe I'll make them bigger next time so y'all can see them. But it's there, I promise. And what we're really seeing from this is there's scattered refugia throughout. It was the lakes, large drainages, and surfaces. We're holding oxygen. You can see Lake Barrett, a lot of white dots. Lake Marpol in the middle, a lot of white dots. Even though it's surrounded by hypoxia, the lake itself is pretty good. Like Buff, Salvador, drainage going into Salvador. I guess that's Bayou des Almonds. All holding oxygen really well, which is great to see. Here's just a combination map where I overlaid fish kill reports and hypoxia, and you can really just see more of that pattern, where you've got these wide areas like around Lake Barrett. You don't see a lot of fish kills down here. You see a lot of fish kills, but we're seeing a lot of hypoxia. So our equipment works and our eyes work. It's good. To kind of shift gears a little bit from the direct impacts of Francine, I want to go back to some of our sampling data and kind of see what all this means in the big picture to us as fisheries managers and really fisheries monitors. What a lot of what we do is monitoring. This is just kind of a cute way that we monitor fisheries. So these are, I just handpicked 3 water bodies within the Barataria to show what we've been seeing really a little bit before Ida and since Ida, and how this recovery is not uniform and it's not easy to digest, really. So we're looking at Salvador, Lake Salvador in the top left, Lake Buff in the top right, bottom left is Lake Catawachi, and the bottom right we'll get to in a second. Don't worry about this graph yet. So these are CPUE graphs. So it's catch per unit effort. This is how many largemouth bass we catch in an hour of sampling. The y-axis on all these graphs, the mean catch per unit effort. The x-axis is our spring and fall sampling, which we have been doing every 2 years in the Barataria, because we have one crew splitting this and the Pontchartrain basin. So they go back and forth between basins. You can see our catches, they're variable as expected. Things happen, sampling bias, whatever. But then Hurricane Ida hits, where those red lines are in 2021. So here, there's Ida. We see a very predictable dip in catch per unit effort in the following spring. A lot of fish died during Ida, but there are still fish left. And this is something we always want to stress to people, because they say, oh, there's a fish kill, go stock fish. There's fish there, they stock themselves much better than us, given favorable conditions. That's the key, given favorable conditions. So if you look at the fall 2022 sample, here, and here, that blue line is substock fish. So that means fish that were born that year, those are bass under 8 inches. They were hatched that spring and they showed up in our sample. This is what we see as the predictable boom after a major fish kill. Anywhere you go, if the conditions are good, you're gonna have a boom. And I always like to say those fish are gonna be bigger in size and numbers throughout their lives. They should be, because there's not a lot of competition, there's not a lot of predation, and there's a large nutrient flush that happened with all that dying stuff. The stuff that killed them originally is feeding them now. So we saw the predictable boom. We go out this spring in 2024, and the story's not looking so rosy. So what happened, we were all here, 2023 was hot and it was dry. It was record hot and dry. And this is for Lafourche Parish. These are wet years and dry years. So this is basically the drought monitor map for Lafourche Parish. This is 2023. Red's not good for fish. It wasn't good for a lot of living things. And we can see that. What we would expect to see in our 2024 samples is kind of what we're seeing in Lake Bluff and Catawatchee. So this orange bar is stock size fish. Those are 12 to 15 inch fish. So those are the fish that were under 8 inches last fall. They should be 12 to 15 inches now. So you should see this orange bar should grow, which we saw it. Like Buff, Catawatchee, we do see that bar growing. If we look at Salvador, that bar didn't grow, and there's not a lot going on. That's because of this drought. Saltwater intrusion, stressing fish, killing vegetation. It was just not a great place for bass. And if you were a bass hatch that year, you probably didn't have much of a chance. And I just picked out 3 of these to kind of show you the variability that we're seeing from water body to water body. Based on, and it's not just proximity to saltwater, there's also going to be depth and a number of other conditions that are causing this. But for this, I think the saltwater had a lot to do. So this is kind of zooming out even more. These are the 6 water bodies we do sample in the Barataria. And we're seeing, I just want to show you, we're seeing variable recovery throughout. So if we go from left to right, the color starting at blue, that's Lake Buff. Gray is Des Almonds. Yellow is Salvador. Orange is Lake Catawatchee. Blue, the other blue is Intercoastal Waterway, the darker blue. And green is south of Lafitte, which is, you don't really see that after Ida. So we see where Ida hit right here. These are the spring samples, expected to be 4, they were. And we see the boom, we see the jump back, except for south of Lafitte. Really, even before Ida, we started seeing a drop in bass feet, and that really has recovered. But you can see the boom that we expected, but here's where you can really see that variability in how different water bodies are responding to storm, little summer drought 2022, big drought 2023. We've got, again, like that's Buff, that's Catawatchee, but this is Des Almonds, Salvador, and Intercoastal. It looks like that size class that was born in 2022 really didn't recruit into the next year very well. And now we had Hurricane Francine, so that brings us this. Our crews are out there sampling. They've had a couple hiccups, equipment malfunctions, but we're working on getting our fall 2024 samples, which will be really telling. I'm really excited to see what those data say. And I really just love seeing how this plays out over time. And it's a shame to see all these disturbances and it's killing fish. But I see dead fish as data, and I see it as information, feeding all of what we're seeing. We'll be hearing from later on today with the climatologist and everything. So, and for a little discussion, kind of in conclusion, Hurricane Francine was less severe than Ida, but there was substantial overlap. Ida only went as far west as Gibson, I think. Francine, we saw through the very low Atchafalaya around Morgan City to Bayou Teche. Low Bayou Teche, so it went a lot further west. The good thing was there's a lot of refuge from Hurricane Francine's impacts. The system obviously is all the help it can get with a recovery, with a natural recovery. But we are seeing compounding impacts from Ida and drought, and who knows what's in store in the future. And the key is we need favorable conditions to recover and support fisheries. We get a lot of calls after a big fish kill to go stock fish, go stock fish. If the conditions aren't right for those fish to stock themselves, those fish aren't going to do well. These big open systems, we know stocking fish doesn't do well. And also, we're just tracking largemouth bass here, but this is a symptom or a sign of a system of recovery. Obviously, if largemouth bass aren't recovering that well, the freshwater system's not recovering that well. So throwing a whole bunch of predators on top of a system that is kind of lagging in recovery is probably not a great thing to do. Going forward, in the past, sure, Quentin, you're a part of the, I don't even know how many estimated fish died from Andrew, but there's a number out there. I made a number for Hurricane Ida because I was asked to, using sampling data and GIS techniques and what percentage of fish probably died in this type of water body and that. You get a number. But if I tell you 250 million fish died, what does that really mean? It's really just a headline grabber. And I saw a headline from Hurricane Ida from the number that I came up with saying, well, there were this many more fish killed in Ida than Andrew. We don't know that. So really what I want to shift towards is more of this kind of qualitative explanation of what a fish kill is. And my terminology might be kind of rough. We probably need to refine it. We have spotty kills, or we have deep kills, or widespread. But I think that's how we need to communicate it better. As a comparison of what we've seen in the past, and just try to explain it as best we can without bringing numbers in. Because if I have a small kill that happens on a Tuesday out here, yeah, we can go count fish, we can make estimates, we can subsample, we can estimate how many fish die in a kill. But when you're dealing with 2 million acres, a kill that could be going on for 3 weeks or a month, you can't estimate that. It's really triage what we do with hurricane response. For me, I want to see dots on a map, and I want an idea, a descriptive idea of what people are seeing all over the place. We need to better communicate fishery impacts and recovery to the public, and that is we, as in the collective we in this room, that's us as LDWF. I think all of us need to help people understand what is happening, because we're seeing lots of fish kills with these weather events we're seeing. And the public has certain expectations that they need to be educated on. We are increasing sampling in the Barataria. As of this year, we've set our operations plan, and it's stretching them thin, but our crew is planning on doing annual sampling in the Barataria now for largemouth bass, because we are seeing all these impacts, and getting a sample, 2 samples every 2 years just isn't cutting it. So we want to have a better idea of what's happening. And really continue to engage public for fish kill reports. I cry out to people everywhere I go, report fish kills, tell me about dead fish. We can't help you if we don't hear about dead fish. And I will tell you, we had a meeting with the Atchafalaya Basin, and I stood up in front of all those people, there's 130 people that want to do something for the fishery. I said, we need to know where there's hypoxia. We know where there's anoxia. Call us when you see dead fish. We did not get one fish kill report from the Atchafalaya Basin from the public, all the ones we got from our staff out there. So we can't be everywhere. Our crews are 3 people, and we just can't be everywhere at once after these. So if y'all ever see dead fish, you can email me, you can call me. The easiest thing to do if you see a fish kill is Google LDWF fish killer, LDWF fisheries districts. It will give you our dispatch 1-800 number. It will give you all of our inland and coastal study areas, what parishes they cover, and phone numbers for them. I could put all that up there, but you don't need that, just Google. And with that, I appreciate it. Thank y'all for having me out.
I have, two questions. First question, two parts. You kind of answered it just here, but my question was, how does the public report a fish kill? And then how does LEWF verify that public report? Like, if I see a fish kill, do I take pictures of it and then I email it to you? Is there sort of a, because I think we could get the public more engaged if there's like a social media campaign after the storm that says, if you see dead fish, please take a picture and text.
And we have been doing that. Every summer, we've started putting out a summer fish kills press release. And I've been on numerous news and newspaper interviews about that. Whenever we see a storm coming, we send a press release out and we put it on social media saying if you see fish. And we also have partners that are like just people with Facebook pages that do put up the information. So it's getting out there. If you want to report one, the easiest thing to do, you can, pictures are great because we investigate every kill. Investigating every kill doesn't necessarily mean we're going out to every kill. We can, because like last Monday, we had 4 kills in one area that a district was scrambling to get in 40-mile-an-hour winds. We do what we can. So the more information, the better. When you report it, pictures are great. Just any observations. The basic thing we need is an address or coordinates and a basic description of what you're seeing and when you saw it, when you started. A lot of people, believe it or not, wait a week to report a fish kill. And to us, we can gauge, like, yeah, there's probably a fish kill here, but we can't follow up on that very well. So time is of the essence, but really just getting in touch with any way you can, because every person that called in a fish kill after Francine, I was on the phone with getting information from. So
if you say email you, if there's a fish kill, is that the best way to do it?
For you, I'm not gonna tell everybody. The best way to do it is, yes, and if you're in the group, you see.
For the general public.
General public, no, it's calling dispatch or calling the district office. Yeah. I'm the fish kill coordinator, so I'm usually sitting there scrambling, forwarding emails to districts, finding out what they're seeing and putting it all in one place. I will take them and I will happily take them, especially after a mass event like this. I'll take them anywhere I can get them. Whatever's emailing me is easiest. Yes, it's great.
Cool. My second question was about shrimp, and this may not be your expertise, but after the storm, and typically after storms, commercial fishermen do really well because I guess the storm surge, whatever. I don't know the science of it, but the shrimp are coming out of the marsh and into the nets. Does any of this impact the shrimp in terms of the amount of oxygen that is available for them?
I can't speak for French or for shrimp. I can't speak French either, but I can't speak for shrimp. I am an inland fisheries biologist, but there's a lot going on there. They're probably moving in because there is a lot of rotting debris. There's a lot of nutrients in the system. I'm sure they do die from hypoxia, just like everything else. We mostly see in fish kills, you mostly see large fish. Unless you're right on it, small fish fall out, inverts fall out. You just don't see them a lot. And they're getting eaten. That's the thing down here. It's not just gar and shoepig. There's still a lot of fish eating fish during a fish kill. Because the first ones die are usually menhaden, pogies, shad, stuff like that. But yeah, I have seen crabs and shrimp in kills, but it's not common to get that report because they're delicious and they're dead.
Thank you.
Yes.
You were talking about Lake Salvador, and I was wondering if you looked at, was Davis Pond closed?
Yeah, and if you were the Finfish Task Force yesterday, there was a talk that went more into specifics on Davis Pond and the flows and what was going on there. I can't remember exactly during this what was going on.
Well, we know that Biologist is not part of Davis Pond, and Davis Pond is not usually operated for fish options. But I was wondering if y'all had any say so. It seems like a way to mitigate when you really think a hypoxia event's going to occur. Seems like you could pour more Mississippi water into that area.
Yeah, and that comes up a lot of times after the fact, the flushing. But yeah, I don't know of any preventative Davis Pond opening. And really, once that storm hits and starts turning it up, even that water is fresh coming in, you're still going to have hypoxia there probably. But after the fact, to get that water freshened back up. It definitely does. I know they do it on biologist. Yeah.
So Robby, in your presentation, you said, after Francine, you know, you get like the video tag several days after the storm. And then you said that the fish were moving around, trying to find refugia. And so can you describe like what features, underwater features there would be that would be these refugia and, yeah, that.
So I would think a little more depth, just gonna have more water to hold oxygen. I think the big thing is being open and being able to have that interchange between the atmosphere and the water, through wind, just getting water, oxygen, keeping that water oxygenated through wind action. Because a lot of what we're seeing, where we saw these kills was right angles, canals, straight lines, small bayous that are sheltered, that are stagnant. You've got water moving through and water stirring up. It's going to stay oxygenated pretty well. And I'm glad you mentioned the fish moving too, because I don't think I touched on that, because that's also where what I call a rolling fish kill happens. You have fish running from hypoxic water, and then they pile up in a slough or just a dead end or just in a bayou somewhere. And then they breathe all the oxygen, and then they end up killing themselves because they breathe the oxygen trying to run from hypoxic water. So again, these things are very dynamic and moving at all times. Is that it?
Any other questions for Robby? All right, thank you, man.
All right, thanks, y'all.
All right, everyone, our next presentation is going to be from Dr. Cassie Glaspie. And she is an assistant professor with, from LSU with the Department of Oceanography and Coastal Sciences. Her presentation is going to be on Gulf hypoxia mapping crews. And so Dr. Glaspie received her BS in zoology at Michigan State University and her PhD in marine science at Virginia Institute of Marine Science, College of William and Mary. She completed a postdoc from Oregon State University in Fisheries and Wildlife. She is now an assistant professor at Louisiana State University and the head of the Marine Community Ecology Lab. Her research involves predator-prey interactions between marine and estuarine species and how these interactions are expected to change with global change, including habitat loss, acidification, and extreme weather and hypoxia. And thank you, Dr. Glaspie.
Thanks for that introduction, and thank you all for inviting me to speak here. I'm always very, very excited to talk about the hypoxia cruise. So this is something that I've been working on with Dr. Nancy Rabelais for a number of years now, and now I take a team out to run the hypoxia mapping cruise every summer, the last week in July. And I'm going to tell you a little bit about the cruise in general and some of the results from this year, and then I'll have plenty of time for questions. So this cruise, if you're not familiar with it, it's an annual cruise to map the size of the hypoxic zone, also known as the dead zone offshore of Louisiana. Happens every year at the end of July, sometimes stretches a couple days into August. And it covers the shelf, the continental shelf, so offshore waters west of the Mississippi River Delta. And it's designed with a series of fixed locations for sampling. It's designed that we will visit all of the stations to completely encompass the area of bottom water that has dissolved oxygen less than 2 milligrams per liter, which we know from Robby indicates hypoxia. So we basically go until we run out of hypoxic water. And the goal then is to calculate the area of bottom hypoxic water, which is one of our major indicators of how our shelf environments are doing and how we're able to deal with all these extra nutrients that make their way out from the Mississippi River. So this is a really valuable tool. I'm sure that many of you are interested in nutrient pollution and We're interested in nutrient pollution's effects, not just in the coastal estuaries, but in offshore environments as well. Both environments support major fisheries that are influenced by things like nutrient pollution. And this cruise has been the principal measure for the status of and trends in the hypoxic zone since the 80s when it started. So we've been, well, not we, Nancy has been conducting cruises since 1985, and I'm a recent addition with very consistent methodology. And so we have this beautiful time series from 1985 to present, which is an extremely valuable thing for us to have in Louisiana. We don't have very many long-term data sets in the South. And so this time series is something that we can use to keep our finger on the pulse of our environment and any sort of management decisions that are happening throughout the watershed. And so this is also the key metric to assess our progress towards nutrient reduction goals in the Mississippi River watershed. And the Hypoxia Task Force uses this as a way to understand how our nutrient reduction is changing the size of the hypoxic zone. So every year, end of July, that's when we're able to actually test to see what's going on with that hypoxic zone. I also wanted to mention that there's a lot of value-added benefits to this cruise that many people aren't aware of. So this is more than just a cruise to provide that one metric. It has been and continues to be a major platform for collaborative science. And so every year we take out at least one investigator and graduate students, usually from locations in Louisiana or in the South or other collaborators that are doing work here, generally at no cost to them, so they can do science associated with the hypoxic zone. This is something that usually they wouldn't have the chance to do. There really isn't a whole lot of funding for new projects in the hypoxic zone, so this is a really big deal if we want to have added science on the impacts of this area off our shore. This metric that we calculate provides an indication of ecosystem health. And so we're able to see things like, is that hypoxic water making its way inshore? How much of the water column is hypoxic and what kinds of species might that be influencing? And very often we also get a glimpse into how the ecosystem is responding. So for instance, a couple of years ago, I was out in a time where there was hypoxia pushed up very close to shore, and we were actually able to see entire schools of menhaden, huge schools of menhaden, basically stretched out flat in the top meter of water, trying to avoid that bottom hypoxia. And guess what? The dolphins were having a feast. So we're able to get some kind of indication of what the ecosystem is experiencing from this annual cruise. This is also a great training opportunity for young scientists that we oftentimes send your way. So there are not very many options for folks in Louisiana, for students in Louisiana to get offshore or to even have any sort of a part in some sort of like big management kind of cruise or kind of effort. And so this is a really important way to get new young researchers and new young managers involved in this field. And so we take out, generally every year, our science crew consists of undergraduates and graduate students who are completely green to this type of thing. We take them out on a cruise, get them used to working offshore, and that is a really empowering thing for those students. And many of them go on then and seek work here in coastal Louisiana or in coastal systems. So here are a couple of examples of some of the folks that we take out in the field with us. And those top pictures are photos of undergraduates and graduate students who have done their own projects in the hypoxic zone. And then those bottom two papers are collaborative papers that we have been able to produce with other researchers to look at things, for instance, like denitrification, methane oxidation. These are all really important things for our global nutrient budgets and global carbon budgets that we're able to understand because of these collaborations on the hypoxia cruise. I also wanted to indicate that on this paper in the bottom right-hand side, which has now been accepted, is talking about long-term trends in the hypoxic zone. And so we're able to understand how our changing climate and our changing management decisions are impacting this, this feature of our coast because we have such a great time series. Without that time series, we wouldn't really know what was going on, because one year we'd be looking at a drought, the next year we'd be looking at a hurricane, the next year we'd be looking at a flood year. And so we can't have one-off years to understand what's happening to our coast. We have to have something like a time series where we've got a wide range of conditions that we study, and we can look at long-term trends and get rid of some of those outliers where we had strange years with things like hurricanes. And so we're now able to do that. Now that we have a good long time series, it takes longer than you expect, sometimes 30 to 40 years, to really get a handle on what the system is doing and to look for things like tipping points, which could indicate our ecosystem is changing from one state to another. Definitely something the ecosystem managers would want to know about. So this year, the hypoxic zone was larger than expected. Here are a couple of images to show you. So our typical area that we map for hypoxia is shown there in the left image. And so that's going to be basically coastal Louisiana, making our way into coastal Texas, all of that area west of the Mississippi River Delta. That's our typical mapping area. And when we produce our metrics of hypoxic area, we're calculating the area of that red zone. And that's the hypoxic zone. This year, it was just under 7,000 square miles, which is roughly the size of New Jersey. This seems to be about the size that we've been getting in recent years, but we had predicted that the dead zone was going to be a little bit smaller than that, so it was a little bit of a surprise, larger than expected. Generally, our predictions of the dead zone are based on the nutrient delivery offshore from the Mississippi River in the months prior to the cruise. And that's a really good indicator of how big the dead zone is going to be. But in recent years, we've become maybe less good at predicting what the dead zone size is. And so that indicates that maybe there are some other things going on, maybe related to our warming waters. And so that's something that we're looking into and that we're able to do because of our time series. Overall, this dead zone this year was 1.3 times the average size, and importantly, 3.5 times larger than our environmental goal. And so we are not approaching our environmental goal for the size of the hypoxic zone that would limit it in such a way that would indicate that we are improving in nutrient pollution load offshore. So basically, no improvement. Another thing we were able to do this year was actually map the hypoxic area east of the Mississippi River Delta. And we were able to do that because of funding from GOMA. So we had additional funding from the Gulf of Mexico Alliance to do this. There's a lot of interest in this area because of a lot of restoration decisions and increase in harmful algal blooms that's happening in the waters that Louisiana and Mississippi share. And so we were able to go out there, and sure enough, we found hypoxia. Anecdotally, and from other efforts that are mapping hypoxia inshore, we know that it's there. The only reason that it's not included in our shelf-wide cruise is because historically, we have not been there. And so there's no funding to go over there, and there's no long-term data set to keep up. But we know it's there, and it's stretched pretty much as far as we could go. We didn't even cap it off offshore of Mobile Bay before we had to turn around and come back because we were out of boat days. So we definitely found it. It's definitely there. And one of the interesting things that we noticed in the samples from the east of the river is represented by this graph. So this graph, I mainly want you to focus on the blue lines, which indicate the oxygen. And the oxygen cutoff for hypoxia is going to be right about, can you see my mouse? Yeah, you can, cool. It's going to be right about here. And so we started to have hypoxic waters at about 10 meters of depth, and we tracked that down to about 23 meters. And that's the lower 10 meters of the water column. Not only was it hypoxic, but it was approaching zero. And so that's not something that we see very often, but we did notice that east of the river in this new area that we mapped this year. So hypoxia is there and it's pretty severe. Every time I see something like this, I'm like, oh, poor shrimp, poor worms. Like there really is nowhere for them to go. They're not going to be existing up in the water column, 10 meters above the bottom. So hypoxia is not just a bottom issue. It can be an issue for basically the entire water column or a substantial portion of it. And that is what we're seeing. One thing I forgot to mention, I'm gonna move back to this slide really quick, is that notice how the hypoxic zone stretches the entire length of the Louisiana coast. That does not provide any breaks for shrimp or other coastal organisms that use the bottom waters to be able to move offshore. And that also doesn't provide very many breaks for fishermen to be able to capitalize on the shrimp that may be congregating there. And so basically this separates our coastal fisheries, our inshore fisheries from our offshore fisheries, and makes folks that are fishing out those waters have to travel further to be able to get out of those waters that don't support any life. Next, I want to show you the graphs of chlorophyll because I have a couple of interesting things to point out. So we map salinity and chlorophyll while we're out there. It's a pretty easy thing to do while we're taking our bottom hypoxia measurements. And we did that both in our normal mapping area west of the Delta. And one thing we were able to do was bring along Dr. Bing-Ching Liu from Louisiana, University of Louisiana Lafayette. And she was able to get satellite imagery from the new PACE satellite and actually ground truth it using measurements that she was taking offshore. And that's the first time that that satellite's been ground truth because it was just launched this year. And so those are the types of value added things that we're able to support with this cruise is any sort of folks that are working offshore in those waters. It can be quite difficult, quite remote to get out there. You usually need to be on a large vessel. It's a lot of money to get one of those large vessels. We have the lab space, we bring them along and they're able to do their research projects with us. And that's something that's going to add value to our coastal monitoring, because if we're able to sense things like blooms of different types of phytoplankton species from satellite imagery, we can track things like harmful algal blooms without having to actually be out on the water, which can be quite difficult in Louisiana sometimes. Another thing we noticed is that when we were sampling east of the river, we actually had a few stations that were indicative of harmful algal blooms. We were able to take samples there, so we will eventually be able to get the species. But this is an image of the water at one of those locations. It was, I mean, this image honestly doesn't even do it justice. It was slime green. It was like Ghostbusters. And there were some fish that were feeding up in that matrix. So it wasn't like we had a big fish kill associated with that. But there's not enough life out there to feed on a bloom that big. And so that bloom is eventually going to die and sink and cause more hypoxia. In addition, if they were a species that was producing toxins, which we suspect they were, those could produce fish kills down the line as the toxins were being produced. And so we're able to kind of see what's going on out there. Almost every year we come across some sort of harmful algal bloom. Usually it's trichodesmium, which doesn't look slime green like this. This year we found likely 3 different species of harmful algal bloom phytoplankton. And so we were taking samples as we go, and that's another value added benefit that we have when we're operating this cruise. So into the future, next year, we're also going to go east of the Mississippi River Delta. So we'll have a couple of years of data. We can see what that gets us and start talking with GOMA more about whether they want to continue that. We are continuing looking at the microbial ecology of the hypoxic zone with Dr. Joy from UGA. And so she has been finding a lot of interesting things associated with how microbes use that hypoxic zone. And that can have repercussions for nutrient cycling and carbon sequestration. So we're really interested in that. We have been looking to see what long-term dead zone areas. So there are some areas of the dead zone that really, the dead zone appears every single year in those areas. We basically have oxygen removed from the water in those areas every year. And so the infauna, the benthic organisms that are living in the mud are really depleted. And we have some indication that we've lost entire groups of species. And so we're going to continue looking to see what those communities down in the mud look like, because those are important food sources for crabs, shrimp, lots of different species depend on the things that live in the mud. We're looking at expanding our monitoring capabilities using new technology such as AUVs or an MVP, which is a moving vessel profiler that's pulled behind a vessel like the Pelican, or maybe even a smaller vessel that will be able to measure the dissolved oxygen in the water column between the stations where we sample. And so that could be something that we add to the time series to provide better coverage. We're going to be looking at the impacts of recent drought. It was still really salty out there this year. I know technically we're out of a drought, but I don't know if anyone told the ecosystem that. So we're going to be looking to see what that recent drought is going to be doing to the hypoxic zone for the next couple of years. And then looking forward with the river diversions, those are very likely to change the way that water flows into coastal waters and the way that nutrients are delivered into coastal waters. And so we're really interested to see if it has an impact on our the size or the location of our dead zone. Maybe it'll break it up a little bit. Wouldn't that be nice? We don't know unless we go out there and look. So we're hoping to keep this time series up long enough that we can see the impact of those large management decisions in the state. And that's all I have for you, but I'm happy to take questions.
So, I know you're looking at the nutrient inputs for the city. Is anybody looking further west for million, especially Mermentol? I know there was a paper years ago comparing the calcium speed and Mermentol significant inputs. Is anybody looking at that?
So the question is, we usually calculate the estimated size of the dead zone from inputs from the Mississippi River, but what about some of the other inputs to the system? As far as I know, most of the people that are looking at other inputs to the system are looking more at hypoxia in coastal water bodies, not so much hypoxia offshore. I don't think that anyone's really been looking at that connection. However, if we're able to map more hypoxia to the east of the delta, there's definitely more rivers over there that are contributing to that hypoxic load. It's not just the Mississippi River plume. So mapping that zone and having an understanding of how that changes from year to year with input from other rivers, I think could be really valuable. But I don't know necessarily anyone who's making those connections, at least not in a formal way yet.
Any other questions?
Got one back there.
Yeah, you have a working hypothesis as to what would explain the difference that y'all are seeing for this year.
Yeah, so every year we take a look at all of the weather conditions to try and understand what's going on with the hypoxic zone that makes it, in this case, larger than expected. It was also pushed inshore further than it usually is. In many cases, we couldn't even get the Pelican shallow enough to cap off the hypoxic zone, which is not normal. So normally we lose it when we get pretty close to shore. So we looked at the winds in particular. So winds they play a large role in moving around that hypoxic zone. They push water inshore if they're coming from the south. And sure enough, this year, before the mapping cruise, we had almost all of our winds coming from the south. We also had some fairly strong winds. And so that was pushing all the hypoxia inshore. And it's likely the reason why we had this continuous hypoxic zone and hypoxia in such shallow water.
So I can tell you, we need to share notes somewhere because.
We just started talking, don't worry, it'll happen.
Well, we saw a very early fish kill season this year. So usually June or so, it's everybody expect fish kills. I think it was April, May, we saw when there were a lot of storms, and I think a lot of nutrients bound up from the drought and started flushing also fish. So.
Yeah, I had a concern about the nutrients being bound up from the drought. I mean, we could just, they have to be somewhere, right? If they're not being flushed into the bodies of water, then they're probably going to be eventually once it starts raining again. So I would definitely expect that plays a role in strengthening the size of the dead zone. Though to be honest, we had a lot of competing hypotheses, like sometimes drought really helps deplete the hypoxic zone. It helps with mixing. Because when we have drought, we don't have a strong surface fresh layer. And that fresh layer oftentimes prevents oxygen from mixing deeper in the water column. So that could have made the hypoxic zone smaller. We usually have a suite of things like that that are going on in any given year that help us to make predictions, and some of them are contradictory. I do think that it's very likely that there were some nutrients that were bound up in the watershed, and after the drought abated, that we saw the impacts of those in coastal waters. I also wonder if maybe some of the fish kills that you were seeing were a result of some of this hypoxic water from offshore being pushed in. No, it's way inland, yeah.
Yeah, I'm not statewide. We've
Yeah.
seen this spring, early or mid springs, so it's all right.
Mhm.
That's good to hear you say that, 'cause that's just kind of a guess about it.
Yeah,
So the, cruise is not of the dead zone side of July. What is the duration?
the dead zone, the duration is a lot longer than the snapshot that we provide. So generally, what we try and do is map the dead zone during its peak, which at least in the past has been towards the end of July. And because we have gone with that in the past, that's what we stick with. Though we know from looking outside that now it remains a lot warmer longer. And so I would expect that the dead zone probably worsens even after we map it in July. The dead zone persists from just after the spring blooms, so it can start popping up in late spring, early summer, and it generally persists through the fall until we start to get those large storms offshore that mix it up. And so this year, it probably is still out there. We haven't really had a whole lot of really strong storms yet, mixing things up out there. We haven't really had our big cold fronts yet. So I guess May to November. So yeah, we don't have that long time. There's nothing to monitor it during that long period of time. This is really the only snapshot we have. It used to be that there were moorings that were offshore that were able to monitor the hypoxia formation and depletion in like specific locations, but we don't have any moorings like that anymore. Yeah.
Next satellite where we get some formula, are you looking at any additional remote sensing to help you expand what you do?
So remote sensing is really difficult when it comes to the hypoxic zone. There are a number of reasons for that. First of all, there's no real clear connection to what we can image from above the surface to what we see below the surface with hypoxia. So things like satellites are really great for tracking what's going on with the phytoplankton, really great for tracking harmful algal blooms, but not so much for tracking the formation of hypoxia. There's a lot more that's going on there. There has been increasing interest in using robotics to help us sense the hypoxic zone, without having to send people out. That's proven quite challenging because we get hypoxia in water that is, 100 feet deep all the way to basically, 5 feet deep. And so the same kinds of challenges that the pelican experiences are compounded when you're looking at robotics. Either it's built for deeper waters or it's built for shallow waters. But there are ways around that. We could use multiple devices to map different parts offshore. And so these are conversations that my group has been having with NOAA and with folks from USM. They were actually out there. Their robots were out there with us this year, and so they had unmanned. Basically, they look like giant surfboards. They were able to send down CTD and sample the dissolved oxygen in a profile. And we're going to be comparing what we were able to calculate using the methods that we've used for this entire time series to what they were able to get, to see if they're able to actually capture that bottom layer. Sometimes the bottom hypoxia is confined to the lower 1 meter of water. And if you think about something on the surface that weighs about as much as a surfboard, lowering a device all the way down to the bottom, avoiding entanglement, you can see the challenges that might arise. And so these are the types of things that we're thinking through.
Any other questions? All right, great presentation. Thank you very much.
Well, it's my pleasure to introduce our next speaker. Many of you will recognize him from his nearly 30 years serving as chief meteorologist at WAFB Channel 9 News in Baton Rouge. He spent about 25 years in higher education as well, studying climate and weather at LSU and the University of Delaware. He was our state climatologist from 1991 to 2003, and earlier this year it was announced by Governor Landry that he was going to have a do-over, I guess you could say, or a do again, and is now serving as a state climatologist with the Governor's Office of Homeland Security and Emergency Preparedness and the director of Louisiana's Office of State Climatology at LSU. So please join me in welcoming Jay.
Thank you, Brent. And I tell everybody, hold the applause to the end because you can't take it back if you choose to. Are you loading in the back? Okay, thanks. So, yeah, it's round 2 or version 2, I guess, if you will. I guess maybe I didn't get it right the first time, so they're giving me another chance. It's an opportunity here to change a little bit the focus of the state climatologist. I'm replacing Dr. Barry Keim, who stepped aside, and with Dr. Keim running the climate program, it was much more of an academic focus. So I'm not that smart. In fact, people say all I do is count things. So I'm back to counting things. And we're going to start counting a little bit of the weather and climate numbers in Louisiana. And hopefully, with time, you're going to maybe even reach out to my office and look for us to support your efforts. So let's go ahead then and get to a couple of different topics. It says climate, past and future, and we'll talk a little bit about that. But I want to talk about, first off, what's going on right now. So let's see if I've got this working here. There we go. So how about just some assorted topics? Actually, the original title was random topics, but my partner said that was too informal. So assorted topics in weather and climate. Let's first start off with what's going on there right now. And there is Tropical Depression 19, soon to become Sarah. By the way, one of the things that I do with the new appointment in GOSEP is I provide a morning briefing, which is probably more so than anyone else. I can't wait for hurricane season to be over because I have to have the briefing out the door before 6 a.m. So I've been getting up at 3 and 4 in the morning for the last 2 months now because Mother Nature just won't give it up. So here's a look at what the National Hurricane Center is suggesting with what will be Sarah. Moves into Central America and kind of meanders there for a while. Good news for us because it keeps out of the Gulf. Bad news for parts of Central America. In fact, right now they're talking about possibly 20 to maybe even 30 inches of rain in spots in Honduras, and that's over a 2-day spell. Well, you can imagine what that's going to do, especially any of you that can, or maybe even still suffering from flashbacks from August 2016. We're talking about the same kind of event down in Honduras. So after Sarah does move into the Southern Gulf, you'll notice that most of the models are taking it off to the Northeast. Not going to be a threat for Louisiana. Excuse me. The one bit of good news for Florida is that previously we were looking at a storm that was likely going to become a hurricane. Now, with its time that it spends over land in Central America, that will limit its ability to intensify, and Florida may only have to deal with a modest to a strong tropical storm. Not taking hurricane strength off the board entirely for the Florida Peninsula, but certainly at least not at one point. There was some chatter about Cat 2 or Cat 3. So it moves into the Southern Gulf early next week, turns to the north and northeast. Steering currents are going to protect Louisiana, which is, hate to say it, but as I get older, I don't want to wish bad things on other people, but I don't need it here. I don't need the overtime. And then lastly, not a concern, other than the swells that they will see down along the coast. Another ongoing weather and climate story is the saltwater wedge that the Corps has built the sill on the Mississippi River, stopping that, excuse me, northward advancement of the sill. We're hopeful that we'll start to see more rain in the mid and upper portions of the Mississippi Valley. And you'll notice here, this is the trace of water levels at New Orleans, Carrollton Gauge. And over the next 5 to 7 days, we do expect to see a bit of a rise on the river, taking it maybe to 6 feet and then settling back down at around 5 feet. But keep in mind, this is the time of year where the Mississippi traditionally is at its lowest flow anyway. So running at about 5 feet would be close to normal for this time of year. And if we can get some rain in the mid and upper portions of the basin over the coming weeks, we will be able to say goodbye to that migratory saltwater wedge. And I think we will see some rain in the Ohio Valley. We'll talk about that in a minute. Drought was mentioned by both of our previous speakers. One of the other assignments, in fact, 2 of my 8 assignments as the new state climatologist is monitoring the weekly U.S. drought monitor for Louisiana. So this is, you're actually getting a flash at the map before you're supposed to see it. So don't memorize anything. Actually, I think it is out now at 10 a.m. But we have had yet another dry year here in Louisiana, especially in the northern half of the state. And that has prompted, and in fact, Robby showed a little bit of this graphic. This is statewide. And what it shows is the drought monitor indicating what now is our 3rd significant drought in Louisiana in the last 20 years. Now, a little bit of good news here. This event won't be as long in duration as the previous 2. The bad news is, in terms of peak intensity, this drought of 2023, 2024 has been a little bit more severe. That's kind of intriguing to me, going way back before some of you were born. How many of you remember the brown marsh phenomenon? Where is it? You would think that in this situation here, we would be looking at some of that, but it hasn't materialized. So that, to me at least, suggests to some degree that climate might have been a factor in brown marsh, but it maybe wasn't the drive. So peak of the intensity last year, 23, 24, a little bit of a break during the early part of this year, and then we had a rebound of the drought in recent months, mostly for the northern part of the state, although even though it didn't get quite as dry here in the southeastern part of Louisiana, we've been looking at record heat over the last couple of months. So this is a look at the drought monitor for Louisiana. As of last week, our updated map will come out later today. And what you will see is that the drought throughout the state will have been trimmed back largely because of the rain that we've had over the last week or so. Thank you very much. Appreciate it. The sinus battle never ends. All right, so let's change gears a little bit. El Nino, La Nina, as scientists, most of you are aware of it, but I often like to just kind of give a little update for those folks that are just a little bit behind the curve, so to speak. And so what we're talking about is a phenomenon in the Pacific Ocean that through teleconnections, in other words, patterns that develop elsewhere in response to the activities over the Pacific Ocean. And one of the things that we need to remember is that the ocean and the atmosphere are 2 fluids that interact with one another, and an energy change in one creates an energy change in the other. And that's what we're looking at here when we talk about El Nino and La Nina. Because almost every time I bring this up, most of the general public just doesn't understand how can something in the Pacific affect us here in the Gulf Coast region. Well, first of all, on a global scale, they're not that far apart. But more importantly, we change the pattern of energy in the Pacific Ocean. That changes the pattern of energy in the Atlantic Ocean above it. And then that energy change gets translated downstream and has an impact in our neck of the woods. And in fact, probably at least some of the drought we've been dealing with over the last couple of years is related to that ENSO pattern. El Nino, Southern Oscillation. The Southern Oscillation is the atmospheric signal, and the El Nino aspect is the ocean temperature. So again, a graphic, little cartoonish graphic here showing you sort of the picture or the disposition of the ocean temperatures in the Pacific during El Nino. And during El Nino, we typically see warmer than normal waters, a tongue of it, if you will, above normal sea surface temperatures in the eastern and central equatorial Pacific, represented by the yellow, oranges, and reds there. And why is that important for us? Well, in the winter months, that tends to enhance the subtropical jet. And why is that important? Because that is what can create more frequent Gulf lows. Now, keep in mind, we're not talking about tropical lows here. We're not talking about non-tropical lows, or as Dr. Glaspie was sort of suggesting, frontal activity over the Gulf of Mexico. That is El Nino. Now we're moving into La Nina, El Nino's evil sister. Now, during La Nina, we tend to see cooler than normal water temperatures in the central and eastern equatorial Pacific. And the flip side there is less frequent, less persistent subtropical jet, which means fewer storm systems in the winter and spring for the Gulf of Mexico. So we could see a bit of a drop down in that activity. For agricultural and on-land purposes, what that means is with that more active subtropical jet during the El Ninos, we tend to see a wetter coastal margin. Our winters and springs tend to be wetter during El Nino. Flood threat goes up. La Nina, flip side there. Our winters and springs tend to be a little bit drier, not necessarily drought dry, because remember, in the winter and spring, especially the early spring and winter, rainfall exceeds the evaporative demand. So those are surplus months in general. So bringing the rainfall down doesn't necessarily harm the environment, but it can be good news for communities because the flood threat comes down a little bit during La Nina seasons. The other thing I want you to notice with La Nina, this map here, and hopefully you can see the colors. Notice the Ohio and the Tennessee river basins get wetter. Good news for the Mississippi River, because that accounts for about 60% of the Mississippi stem flow. So a wetter Ohio and Tennessee basin will bring more flushing waters downstream, down the Mississippi main stem, so that as we get into the winter and spring, hopefully we'll flush out what's left of that saltwater wedge. So in reality, La Nina is not a bad thing for us in the winter and spring. So how does that shape up? Here's a look, and this is probably almost impossible for you to see in the back, and my apologies. This is a weekly animation of sea surface temperatures in the Pacific. So get your bearings, South America, the coast of South America on the far right. You see Australia down in the bottom left. And what it shows you is that typically the water temperatures in the Western Pacific are generally warmer than water temperatures in the Eastern Pacific. Well, what happens when you warm water? What happens to the water column? the water expands. So in reality, and that is a pattern that's representative in both El Nino, La Nina, and the middle, neutral or tongue-in-cheek, La Nada, the nothing. So typically, the Pacific Ocean is higher on the western side than it is on the eastern side, driven largely because of the water temperature differences. Well, if you had a soup bowl like that, what would it want to do? Slosh back. So it's the 8th grade explanation, but that's part of the flip-flop process. It contributes to the flip-flop process of La Nina and El Nino. What piles that warmer water to the west? Because traditionally, the winds near the equator flow from east to west. When those winds relax, the soup bowl sloshes back, and we start to move warmer water back into the central and eastern Pacific. This map representation here doesn't tell us what we need to know. What we want to look at are the weekly water temperature anomalies, and that's here. Now, where you see areas that are orange to red, that's where water temperatures are warmer than normal for that week. And where you see shades of blue, that's where the water temperatures are cooler than normal. And I think your eyes are drawn to that patch of blue, the onset of cooling waters in the central and eastern Pacific. Now, I got to admit, the experts have been talking about La Nina on its way for almost half a year now. But I do think it is going to arrive as we move into the winter and spring, and that will set us the stage for a somewhat drier coastal Louisiana for the upcoming months. Not necessarily drought dry, but drier than normal, along with that water coming down out of the Ohio and upper Mississippi and Tennessee basins. All right, so here's a long-term look at La Nina and El Nino. Red is El Nino, blue La Nina, and the swath in the middle is that La Nada, the nothing, or the neutral phase. First off, neutral phase accounts for about half of all years, and then we kind of split 50-50, 25% each, El Ninos and La Ninas. But if you look a little bit more closely, and some of you are going to say, I don't see it, but bear with me here. There tends to be about every 20 to 30 years, about 25 years on average, where there's a secondary cycle in there where La Ninas are more dominant, then El Ninos become more dominant, and then we flip-flop back and forth there. That, for those of you that watch climate indices, that is probably a reflection of the Pacific decadal oscillation. So what we're really talking about then is a short-term seesaw pattern along the South American coast, influenced in part by a longer-term Pacific decadal oscillation. So we even can sort of anticipate intensities of these events as they come on. And one thing I think you'll see there then is we are likely coming to an end of the 20 to 30 year stretch of dominance by La Ninas. And so we're going to shift again, more than likely, in the next few years, back into a 2 to 3 decade run that'll be somewhat dominated by El Ninos. Now, not good for South Louisiana in terms of winter, but El Ninos also tend to reduce tropical activity in the summer and fall. So the trade-off for Louisiana is kind of El Nino, winter bad, summer good. Francine was mentioned, and in fact, I saw a graphic here of the wind speeds, and what this map represents is the National Hurricane Center's projection of where wind speeds of hurricane force, red, strong tropical force, yellow, and marginal tropical force winds occurred during Francine. And in fact, the #1 call I got after the event was from sugarcane farmers who believe that this might be an opportunity or an event that would impact them from a financial standpoint in terms of qualifying for aid or assistance. Well, here's the depiction of the winds based upon the National Hurricane Center. But here is the depiction. I know you can't see these numbers. Here's the depiction of the observed peak winds around South Louisiana. And while you can't read the numbers, what I want you to notice is, or what I can show you, is there's one red circle on that map. The only location to record hurricane force winds, other than out over the water. And why is this important? Well, because what we're finding is that the Hurricane Center forecast for wind fields tend to be a little bit overdone. Now, that doesn't mean there was only one location that got hurricane force winds. It's the only location that recorded it. But based upon the wind field that you see drawn by the National Hurricane Center, we should have had at least a half a dozen sites that were either hurricane force or strong tropical storm force winds. Those never materialized. Yes?
But there's also under that, the numbers are on the periphery of that red field. So you have to have stations that are recording the data in those.
Look, what I'm
Right? So, so to me, I see, what I see more than anything is a lack of numbers in that red area.
no question about it. And I can only present the data that I have.
I think the numbers, to me, one of the things that's noticeable that there aren't actual recordings for most of that red track.
I understood, but look in the strong tropical force wind zone, and you see those numbers are all below what we would call strong tropical force for the most part. Part of my limitation is what's out there to measure. Right. I get it. My point is that the National Hurricane Center has a job to do. And for those of you that might remember Dr. Roy Daca, he had a line that was something to the effect, I'll paraphrase it here. The Hurricane Center's job is not to get it right. It's not to get it wrong. Does that make sense? Because their job, and if you look at the National Weather Service statement, who is the parent agency of the Hurricane Center, their mission statement is not to observe weather. It's to protect life and property. And so by posting numbers that are potentially higher than what's going to be observed, you're sending a message out there that hopefully the public is listening to. On the other hand, we have to be careful about using maps like that to evaluate conditions that in many cases didn't seem to materialize. All right, moving on now. So let's talk a little bit about tropical weather in Louisiana. So this is the timeline of tropical storms and hurricanes, and hopefully you can see there are shades of yellow and a deeper red. The yellow or the orange represents tropical storms, the red represents hurricanes, and these are storms that impacted Louisiana. So the list is a little bit more than storms that made landfall. And the best example that I can provide for you, for those of you who were here a number of years ago, was Hurricane Ike. Ike did not make landfall in Louisiana, yet as it moved from east to west in the coastal waters, it delivered hurricane force winds along the coast. So it counts as a Louisiana hurricane, even though it didn't make landfall. So this is all the storms going back in time to 1900. So my first question to you as the audience is, do you see anything that strikes your fancy there? Of course. What was that? I think all of us will agree what's going on here. There's been an uptick in activity. The other thing I would like you just to look at briefly, going back to the full graphic, is look. I think most people in Louisiana do not recognize how frequently our state is impacted. In that 120 years there are only 4 times, I think, where we went 4 consecutive years without an impact. And then you look at what's happened over the last 20 years, and somebody out there is really pissed off Mother Nature. And you can see not only has it been active, but look at the array of multiple hits in a single season during that stretch. So not only are there 2 years with 4 hits, but there are 7 out of 20 years, basically, that there were multiple hits. Getting in a little bit tighter at that graphic. Now, this graphic right here, many of you could do it too. I could talk about this for an hour because I can talk about the uniqueness of every one of these storms and how the cluster collectively reminds us of just how perilous the Louisiana coast is when it comes to the tropics. But then you start looking at these individual storms, and each one of them is a story on their own. Let me ask you a question. If you were to identify a single state and say that state gets the nickname Hurricane State, which one would it be? It's not a trick question, by the way. Florida. Of course it's Florida. Florida is like a big Jimmy Durante nose, for the old people in here, sticking out into the middle of the subtropics, saying, hit me. And Mother Nature is happy to oblige. It's got an Atlantic coast, it's got a Gulf coast, and arguably a third coast, the Panhandle. It's 1,200 miles of come on and hit me. But guess what? Their coastline is almost 4 times longer than Louisiana's. But per mile of coastline, prorated to per mile of coastline, Louisiana gets hit more often. Now, that doesn't mean let's all move to Florida, but it just reinforces for me the fact that Louisiana is still a red zone, a hot zone when it comes to the tropics. We don't get the national press that Florida does, but this is ground zero for tropical weather. And by the way, speaking of what will be Sarah, you do realize how active this season has been. It's not going to achieve the crisis numbers that the forecasters were calling for back in May of 20 to 25 storms, probably. But we're at 18 now when Sarah gets a name. And by the way, normally 1 in 3 named storms either ends up in the Gulf or forms in the Gulf. Well, this year we're ahead of that. Half of those 18 storms, when we include Sarah, will be Gulf storms. We have, even though we had to deal with Francine and we're kind of debating on whether we're going to call Beryl an impact, not because Beryl's first passed, but because Beryl came in and got northwest Louisiana in the back door, sliding through Texas, generating all those tornadoes. But this has just been a spell, starting back in the last 2 decades or so, that we just can't seem, when I say we, Louisiana, just can't seem to get out of Mother Nature's way. All right, a couple more slides here, and then I'll be glad to say I don't know to any questions that you might have. First off, statewide temperatures. And if you look at the trend going back into the 70s, you see anything there? Getting warmer. And in fact, this is 2023, the warmest year of record based upon our records going back to the 1890s. Now, a lot of people look at this and they leap at another sign of climate change. And it is another sign of climate change, or at least climate variability. And that's a whole nother discussion. But what I like to remind people is, yep, it's been getting warmer. And if it keeps it up, it's going to get as warm as it used to be. Now, that's a Louisiana thing. This is why you can't use some global discussion and apply it locally. But what to me is more important in that graphic, and what we can explain, is what happened in the early part of the 20th century. Why did we get that drop off in temperatures in the middle part of the century? And then we see this new rebound. That's not a global signal, that's a regional or a local signal. And by the way, that cooling spell in the middle of the 20th century, that occurred across all of the South. So it's not a Louisiana unique feature. A reminder here, though, that variability is important. Now, for those of you that are reasonably comfortable with graphs and statistics, you know we can make this look as bad or as benign as we want by what? Crunching the y-axis. So if we play with the y-axis, we can make this look pretty benign. If I stretch the y-axis a little bit more, I can make these swings look incredibly wild. But here's the thing that I've always said. Temperature and precip. If you had to pick one of those elements as the dictator, the driver of Louisiana climate, which one would it be? I'm only giving you two choices. Oh, and by the way, you're not going to be graded on this exam. Temperature, rainfall. It's got to be rainfall, right? I mean, the temperature variability here, even here over 100 years, is on an annual basis, is only a couple of degrees. Yeah, last year was miserable, brutally hot. This year, the last half of the year, looks like it's going to be a lot like last year. But it's rainfall that is the bigger issue. And if we look at rainfall over time, going back to 1900, we do see a slight uptick in average precipitation, an increase of about 10%. But even then, when I look at that graphic, in terms of agricultural impacts, environmental impacts, coastal impacts, does that 10% outweigh the annual and interannual variability on that timeline? And I would say, not a chance. Look at some of those years where we go, great example back here, where we spike from one of the wettest years on record to the driest one year right after the other. You can imagine how the environment, and more so maybe how agriculture, was unprepared for that. Then we had the super dry spell a few years ago, back in the late 2000s, 2020 to 2010. A run of wet years, and then last year, another very dry year. So one could argue at 1%, or make the argument that whether you're going to call that long-term trend as climate change, to me, from a statewide perspective, climate change isn't nearly as impactful as the year-to-year variability could be in terms of how the state responds. So, my very first introduction as state climatologist V2 was with the governor. And the first thing to come out of a reporter's mouth was to set me up with a climate change question in front of Governor Landry. From a few of the smiles I see out there, yeah, It could have been, I could have been the shortest term state climatologist in history. So I did what every good TV guy does. I ignored the question and answered something else. But here are my thoughts. Is the planet warmer than it was 100, 150 years ago? Yes. Let's just say yes. I mean, we can argue what that temperature change is. And by the way, in reality, what does a global number mean? Nothing. I mean, we have a global average temperature in which there's virtually no place on the planet that averages that temperature. So it's kind of it's a nice tinker toy to play with, but it doesn't tell us much. Are humans contributing to this warming? If there has been warming, certainly we're in the picture. And certainly I've not shown any of these slides to the governor. But here's the thing. It's not just fossil fuels. In fact, fossil fuels may not even be the primary driver. And Louisiana is a perfect example of this. When you take a forest and turn it into a pasture, and then turn that pasture into a Walmart parking lot, what have you done to the local climate? You've absolutely warmed it. So development and landscape change is a big contributor to climate change and global warming. Now, an argument, and a valid one, would be, wait a minute, we've only changed, when we consider that 70% of the planet is water, and even most of the earth hasn't been, dry land, terra firma, hasn't been turned into cities yet, we're only talking about a small portion of the planet. But that's not really true. Because if you look at what's going on in South America, drastic changes in the Amazon. If you even look at the American plains, they certainly don't look like what they did 300 years ago. So landscape change does not simply mean building buildings and neighborhoods. It means changing the surface conditions of the environment. Are human activities the primary driver of this warming? Well, here's where I get in trouble with even folks like you. I don't believe we have enough evidence to say that humans are a primary driver, and there's clearly evidence that there are natural factors at play. However, I will back up with my first statement. Yes, humans are a player in the equation. Should we take action to reduce the human impact? That's a dumb question. Of course, it shouldn't even be a point of debate. That's partly what you're doing here today. Can it be stopped? No. We're too far down the road. Mitigated, but not stopped. And quite frankly, I'm not quite ready to go back to stone knives and bear skins either. So the approach to the solution here has to be, in my view, a technologically sound approach to mitigating those impacts. All that said, even if the impacts of climate change are being overstated, our state may well indeed be one of the most severely impacted of all 48 states, and quite honestly, maybe the most potentially severely impacted state, other than possibly Alaska. So that, again, is why you're here today, to protect our environment the way that we can, using the methodologies that are available to us. And with that, I'll say thank you. And again, happy to try and answer any questions.
All right, thank you, Jay.
See, the applause wasn't as enthusiastic as when I started.
Do you have any questions?
Thank you very much.
All right, thank you. Okay, with that, got a couple of things. Do we have any public comments? Okay, I want to remind, our next meeting is 10th, meeting to be determined. Fine.
If you have, not signed in for whole, just please sign in, front of that, and then we can, and then that, I know, we want to make a motion to her. I'd like. Oh. Yeah.
Thank you. I just wanted to remind everyone that, we have our Upper Barataria-Terrebonne watershed webinars and workshops project that's going on. And everyone is welcome. These are usually, at least the one of them that's coming up is in Zoom format. So there are two of them coming up. The first one is going to be on, November 21st. And that's at 1 o'clock, and it's going to be in Zoom format. And we're going to be discussing water quality, TMDLs. Okay, all right. And so we're going to have Jerry Davenport with Louisiana Department of Ag and Forestry with the Upper Delta Conservation Projects is going to be talking at that one. And then on December 3rd, we're going to be meeting in person on location in Marigold, Louisiana Community Center. And we're going to have Melanie Bowder, who's here from Louisiana Department of Environmental Quality. She's going to talk about non-point source pollution watershed activities in Bayou Marigold and Bayou Grosse Tete, and an update on the watershed implementation plan, as well as John James Clark with Iberville Parish. Another thing I wanted to talk about, and please contact me for more information on how to attend those and in-person meetings. The Louisiana Nutrient Strategy comment period is closing on December 4th. And so there are some things there's some oversights in example. In the current strategy, the Louisiana Hypoxia Working Group is not even mentioned. So please, if you have any comments, go ahead and, go to the website and make your comments. Thank you.
Thank you. Yes, sir.
Back, I have a question.
Sure.
So Terrebonne Parish after Ida, it's estimated we've lost about 6,000 people, which would be almost about 6% of the population, because of housing, because of insurance and all this. Does the state have a plan to try to retain residents in Louisiana as this migration begins to continue storm after storm after storm?
I don't think the state has a plan right now, and I'm not even sure that they're trying to address a full-scale plan. The first solution is going to be get a handle on insurance. That's plan one, to keep insurance companies here, because if you can't get your property insured, you're not going to stay. So that, to me, is probably the first step. Beyond that, you still have to be able to provide residents in the coastal communities a sense of comfort that they're going to be protected. And I think in the last few years, we've seen with the storms that we can't mitigate the storms. And at what point do we even say we can't rebuild in places that are so vulnerable? And then you start, in my view, start running into sort of community cultural issues. You've got people, I've been here, my grandparents were here, my great grandparents moved here a century ago. I don't want to leave. But at some point, I think we're going to have to recognize that some of these communities can't be saved, because eventually another Ida, another Laura, another Delta is going to come. The frightening thing is the frequency that we've been seeing now. The hopeful thing for me is that we're going to get into that La Nina cycle that I mentioned, and at least we'll say goodbye to that elevated number of storms. They're not directly linked, but that same 25 years of elevated activity for Louisiana just happens to coincide with the most recent cycle of La Nina intensive, that more common phase of La Nina in the ENSO cycle. So hopefully that'll come down a little bit, but there are just too many communities, I think, that remain incredibly vulnerable. Grand Isle being a perfect example. At what point does that become a community, a sport of kings? The only people that are going to be able to build there are the people that can afford to lose the property and not take it on the chin. So short answer is, I don't think there's a comprehensive plan in place right now. But first step, I think, will be to assure those people that insurance would be available. And even that's going to be a tough road to hoe.
What place in the state government would be able to assist in that planning, do you think? Of not relocation, I'm not saying that, but offering people a pathway to a safer place if these communities that you mentioned are not going to be viable communities in the future. What assistance would those folks have in even developing a plan for themselves to figure out what to do?
Well, that's a great question, obviously. I mean, people that are living there that are going to leave, they're going to get, if there's not a subsidy, they're going to lose everything in their property there. Now, we've seen some programs that have offered ability to buyout opportunities. That's the only solution, but I'm not sure the state can afford that, not to get everyone out of those coastal communities. So you've definitely taken me to the I don't know zone. So, thank you.
Okay, so we're about to adjourn, but I want to say that we have a lot of food apparently. And if you can't stay for lunch, there are to-go boxes. So please stuff as much as you can in there and take it with you. All right, I think we've got one motion to adjourn. Do we have a second? All right, Brian Roberts, all in favor? All right, thank y'all.